Okay. I made the adjustable measuring cup, so I should probably make a measuring spoon to go with it. So I'm going to basically use the same concept as the measuring cup, but I'm going to essentially just make a smaller version. But I will make improvements to the design, because I've been thinking about how the measuring cup works, and there are improvements to be made beyond what I mentioned when talking about the measuring cup. And if this works out well enough, I might even, I might even change the measuring cup to be closer to this design. However, when making a measuring spoon, there is an important design constraint that is there's an important design constraint that a lot of manufacturers of measuring spoons tend to ignore, and that is that it should fit inside of a can of baking powder. Baking powder cans have a hole in them, right, with a straight edge, so that you can easily pull out your measurement. But a lot of measuring spoons that are too big, or that are of somewhat big sizes, tend to not fit in a measuring, or in a baking powder can, which is so stupid. Like, you literally had one job, which was to measure baking powder, and you cannot measure baking powder. So, I just measured the diameter of, because the hole in the baking powder is shaped like that, right? Except it's rounded off. So I measured out the diameter of that hole there. It says 53.3 millimeters. I'll make it 52 millimeters. And I'll make a line that goes across. And I'm going to go ahead and offset this by about 1.2 inwards. Alright, so now since this is 52 millimeters, that makes this 52 minus 2.4. So I'm going to make a line here, make it 52 minus 2.4, and I get 49.6. Okay. I did not feel like pulling out a whole calculator just for that. Okay, I gotta do my... Oh, you know what? I have to pull out a calculator anyways. Hang on. Where's my calculator? There's my calculator. Okay. 49.6 divided by 2 is the radius, 24.8. Square that, multiply it by pi, and then divide by 2, gives us an area of 966.1 cubic millimeters. Okay, so now we're going to pull up Google, and is this Google or is it? No, it's Bing. Well, Bing has a unit converter too. I'm going to go for volume. I'm going to go for cubic millimeter. And I'm going to go for US tablespoon. And 1 tablespoon is 14,786.7648 cubic millimeters. So, if I can round this to about 960, I'll round this to 966 square millimeters, and then I'll round this up to 14,787 cubic millimeters. So now I've got 14787 divided by 966 is 15.3 millimeters. Alright. So I'll go ahead and extrude this by 15.3 millimeters times 2. I might as well make it 2 tablespoons. Gonna take the sketch and make it visible. I'm gonna go ahead and extrude this whole thing by negative 1.2. And there's that. Okay, so now what I'm going to do is I'm going to pull up this and go from tablespoon to teaspoon and go to a quarter teaspoon. 1232.2. That's going to be very small, because if I pull up the calculator, right, I've got 1232.2 divided by 966 gives me 1.27 millimeters. So what I'll have to do is that, okay, I'm going to project this. I'm going to offset this. Can I? No? Okay, I'm going to go ahead and delete that so I can offset this. Negative 0.25. This will go all the way. Gonna extrude this. Gonna start at an offset of 0.01. No, 0.1, and then go all the way to here. And now that's body 2. Okay. So this is going to be the piece that moves in and out, right? So now I got to make a line here and make it go .27 millimeters. And I don't like that. I don't like that right now. So what I'm going to do, I don't like where that is. I'm going to go ahead and change this because I actually don't want it to be there. I want it to be... I'm going to cancel that and then I'm going to change it again. And it was... I'm going to change it to distance. It says 30.5. I will make it about 30... I'll make it 40. Yeah. The reason I'm making it bigger is so that I can add a piece to the top of the whole spoon that extends out the back. It's that this will come into. So I'm going to go ahead and start a sketch here, and I'm going to go, no, I'm not going to do that. I'm going to delete this sketch. Now I'm going to start a sketch here. It called it sketch 4 anyways. 1.27 is very tiny, because if I put a hole here, I was wanting to make it about 2 millimeters. Okay, and then I make this perpendicular to this, and then I make another 2 millimeter hole. Put this on the center line with it, and then move these, make that 1.27. That's rough, right? And then make another hole, and then another one, so I get 1.27 times 2 to make a half of a teaspoon. And I really don't know if that's going to work, but I'll design this anyways. So that's a half a teaspoon. I just realized there is also an eighth of a teaspoon. And there's a third of a teaspoon. Anyways, I'll make the whole teaspoon now. So that's 1.27 times 4, right? And that's the whole teaspoon, right? So I've got, this is the 0 point, this is a quarter teaspoon, this is a half teaspoon, this is a teaspoon. Then if I go up to a quarter tablespoon, I get 3,696.7. So 3,696.7 divided by 966 is 3.82 millimeters. So if I make 3.82, that is almost, that is interesting. That's less than a teaspoon. In fact, that's like 3/4 of a teaspoon. Let me see that. 1.27 times 3 is 3.81. Yeah, that's 3/4 of a teaspoon. 3/4 of a teaspoon is a quarter tablespoon. So I'll take that, make it go 3.82 times 2. That's a half a tablespoon. And then 3.82 times 4, that's a tablespoon. And then I do it 3.82 times 8, and that is 2 tablespoons. And that is they are very close together. So something I can do to make them farther apart is change this original sketch to make it smaller so that it would have to be longer. And I think I'm going to do that. So I'm going to change the outer edge to, say, 46. So now I've got to calculate, where's the calculator? I closed the calculator. So now I've got to calculate the area with that. So then 46 minus 2.4 is 43.6. Square that. Multiply by pi. And then divide by 2 because it's a half circle. And I get 2,986.02. So 2,986 cubic millimeters. Or square millimeters, sorry. That doesn't make sense. Hang on. I said 46 minus 2.4 is that. Square that. Okay, that's wrong. Hang on. 46 minus 2.4. I don't know how to use this stupid calculator. Square it. Then times pi. Pi r squared. That gives me the, and then divide by 2. 2,986.02 square millimeters. That doesn't make sense because I had 52 minus 2.4 is, and then squared, and then times pi is, and then divided by 2 is 3,864.4 square millimeters. And then if I go to 2 tablespoons, I get 29,573.5. And if I do 29,573.5 and divide that by what is the most recent number in here? Square 49.6. Okay, divided by 2 is times pi is this, then divide by 2. So I divide by 3,864.4 and I get 7.65. That's how many millimeters that would have to be. I didn't do that right. That's interesting. Okay. So, I'm going to change this to be about 30, right? 30 squared is, I'm going to change it to be 32.4. Alright, so the internal area, or the square area is going to be pi times 900 divided by 2, because 30 squared is 900. Multiply that by pi. And you get this. And then divide by 2, and I have this many square millimeters is the area of that half circle. So now, I'm going to go ahead and take the 2 U.S. tablespoons, 29,573.5295, or call that 0.5. So, 29,573 it was, 0.5, divided by 1,413.7 gives me 20.9, or 21. So I take this and I make it 21. I don't like that. That's already shorter than it should have been. Let me get rid of this second body here. I think the squarer this cavity looks from this angle, the better I will be. So, let me reduce this again to about 24.4. That would be 22. 26.4. Okay. 26.4. Alright. Minus 1.2 on both sides is 24. Okay. So now if I go to my calculator, 24 squared. Oh, I know what I did wrong. Okay. I know what I did wrong. I know exactly what I did wrong. I forgot to take half the diameter. So, if I go all the way back to here and go back to like, what was it? 46.4. Right? Now, 46.4 divided by 2, because that's the radius that I need, and then square it, and then times pi, and then divide by 2, gives me 845. That's still going to be too small. So I'm going to actually change this to, probably the 30s will work better. 32.4. Right? Again, so that'll be 15 squared times pi, then divided by 2 because it's a half circle, gives me 353.43 square millimeters. Now I take the 2 tablespoons, which is 29,573.53, so 29,573.53 divided by 353.43 gives me 83 millimeters. That's too many. So 83 is too many. Because that's taller than anything. So, somewhere in between 32.4 and 56 is the magic number. Call it 42.4, so that would be 40, right? Half of 40 is 20, so that's 400 is the square of that, right? So 400 pi divided by 2 is 628.32 square millimeters. I take the 29,573.53 divided by 628.32 628.32, and I get 47.06, right? Which I can probably just make 47. I'll make 48. And that, if I do a sanity check, would be a little bit long, but should still fit inside the... Yeah, it'll still fit inside of a can of baking powder. But now I can take body 2 and then it was 48. Okay. I'll make the extrusion for body 2. No, that's not the extrusion for body 2. This is the extrusion for body 2. And make it 58 for now. Okay. Actually, this should be 58. And this should be 68. That way, when it gets to... That way on this sketch, this one will be 48, right? Because 48 is... I would move this in this direction by 48, right? That would be 2 tablespoons, and there would be this much holding it together. So I should also have more space to make the holes that I wanted. So if I take and go from 2 US tablespoons to a teaspoon and make it a quarter, and I get 1,232.2 cubic millimeters, right? And I'm working with 628.32, right? So I take 1,232.23 divided by 638.32, and I get 1.9 millimeters, which is better, but it's still pretty short. But I'll take it. 1.9, and then 1.9 times 2, and then 1.9 times 3, and then where was this one? This is the 1.9 times 2. This is the 1.9. So this one right here. 1.9 times 4 gives me the teaspoon. And then this one here is going to have to give me the half tablespoon, which should be 1.9 times 6. But I don't think so. Let me just check. So if I go to tablespoon and go to a half, I get 7,393.38. So 7,393.38 divided by 628? Yeah, 628.32 is 11.77. So this should be 11.77, gives me a half a tablespoon. Control Z. This one, This one is that. Alright. And then that's a half a tablespoon. This is a tablespoon. Right? Because I would just multiply by 2 to get a tablespoon. And then we've got 0, quarter teaspoon, half teaspoon, 3/4 teaspoon, which is also equal to 1/4 tablespoon, which makes sense because 3 teaspoons make up a tablespoon. Not for real. I mean, like if you look at this, it goes U.S. teaspoon and U.S. tablespoon. If you put 3, you get 1. Okay, yeah, it's 3 teaspoons for a tablespoon. So that makes sense. Have I ever used a recipe that called for 1/8 of a teaspoon? I think I've seen 1/8 of a tablespoon. Right, so this was 23.54 was the yeah, this is the tablespoon, 23.54. Let me see what 23.54 divided by 8 looks like. Okay, and then there's 1.9 times 2. Let me just Google it. 23.54 divided by 8 is 3.175, and I've got a 3.8, and I've got a 1.9. There it is. And that is 1/8 of a tablespoon. I do not like that. I do not like that one bit. What if I took this and took the 58, changed it to plus 10, plus 10, 48 times 1.25. And then I take this, no, this one, (48) times 1.25 plus 20. And then I take this sketch and then multiply everything by 1.25. Except for that. Okay. So I've got this one, I've done this one, I've done this one, this one, what the heck? Okay, this one, okay, and then this one, and this one. Okay, everything's to times 1.25. This might have issues, but other than that, it should be fine. All right, and then 60 is really tall. It's really darn tall for, but it can still go inside of the baking powder. It does become really annoying though, because if I ever need 2 tablespoons of baking powder, which I never will need that much baking powder, right? I'm probably gonna only ever need a tablespoon. So okay. So if I extrude all of these into smaller holes, into little holes, -3, just to be safe. This is what I'm scared of. This is what I'm scared of. Okay, so now what I'm going to do is I'm going to make a sketch here. I'm going to go ahead and I'm going to make a rectangle that extends past this. I'm going to make this collinear with this. Then I'm going to project this hole here. That's the 0. Then I'm going to make another rectangle and I'm going to make this then I'm gonna go ahead and make an offset of this rectangle, make it 1. And then I should be able to move this up and down, right? Yeah, okay. So now I'll make this one collinear with this. Fail to solve. Did something snap to something? Okay. Okay, whatever. Just dimension from here, there, then offset 1. Put a line here. And a line here. And put rectangles on this. Put them over here. Alright, so what I'm going to do now, what I'm doing here is I'm creating a geometry here. I don't know, about, no, 1.4 should work. So what that is hopefully this will be thin enough that that middle bit can move up and down, right? And I'm going to go back into the sketch. I'm going to go ahead and offset this circle by negative 0.1. And then I'm going to bring the sketch, hang on. I'm going to extrude this up by that much, and then I'm going to bring the sketch back, and then I'm going to extrude this circle, and then I'm going to make it disappear. And I'm going to start at an object here, and it's going to be a distance of 1.25. No target body found to cut or intersect. Then I'm going to go ahead and fillet this as far as it'll go. I'm going to change that. Okay, so I'm going to bring back this body. So hopefully this will work to do that. I'm going to make okay, and now what I'm going to do is I would like to make a I think what I'm going to do is I'm going to go ahead and write with letters, or write with a pen, the actual numbers, because I don't think I have enough space to make letters here. But the idea here, right, is that this piece is going to move in and out, right? And it's going to be held in by all the intersections here. And it's going to click into place with these holes, right? And I feel like this is a better... design than with the cup, or measuring cup, because the measuring cup had the same idea. The measuring cup was basically the same idea, but the piece was not in a fixed spot, right? This piece here was not in a fixed spot, it could wobble. And I really need it to not wobble very much because this is a bunch of really small, tiny pieces. I would like to make a separate piece that somehow attaches to this. Yeah, because if I move this all the way under here, yeah, okay. So what I'm going to do is I'm going to go ahead and extrude. No. I'm going to go ahead and start a sketch here. I'm going to go ahead and project this plane here. I'm going to go ahead and extrude this by about 2 millimeters. Right, because the original dimension was a total of 42.4. Add 4 to that and you get 47. So I should have space to do that still. And then I'm going to go ahead and take and make a mirror plane, a mid plane between here and here, and mirror the features of this extrusion on this plane, make it identical. Okay, so what I'm going to add now is a piece that slides up and down. So I'm going to make a sketch on this plane here. Gonna go ahead and project all of this. Gonna go ahead and offset it by 0.25. Okay, so I've got 47. Add 4 to 47, you get 51, and the total was this only has to be 1.2. The total was 56, so this should still fit. It'll be a little snug, but it should be fine. Extend this, and then trim it. And then dimension from here to here is 1.2. And then I'm going to extrude that. Whoops, hang on. I forgot to vertical 1.2. And same thing on the other side. Make it 2 actually. Go ahead and extrude all of that now. And this is a piece that will slide back and forth to level off the measurements. Get rid of the 2 bodies, and then did not want to include that. Yeah, there we go. Make it 2. Alright, so now I've got 3 bodies. I've got the actual cup part, I've got the actual measurement part, and I've got this thing here that will level off the measurements. I'm going to do something. I'm going to go ahead and extrude, not that part, not that much. Okay. Make a sketch here. Line going all the way down to there. And there. I'm going to go ahead and extrude this. All the way to here. The reason I'm going to do that is so that I can add in this little extra bit of space. So dimension from here to here. Yeah, okay. Then I'm going to go ahead and make a rectangle there. And make a rectangle here. Make this one collinear with this one. And then make this height equal. And then put a midline here. Mirror these. And then cut these out. Okay, that should give it a little bit more wiggle room. Like it literally needs more room to literally wiggle. So this is just a concept. This is just one proof of concept. So, yeah. I'm gonna go ahead and rename these now. This is the cup. Well, this is the spoon, actually. And then this is the... I think I'll name it spacer. That's more descriptive of what it does, I think. Name this leveler. And then I wonder if I'll have enough. I wonder if I'll have enough wiggle room to do this. I don't know if I'll have enough room to actually do that. But the idea here is if I have enough room to be able to like bend it enough to put this, to like snap this into place, then the leveler will become a permanent fixture in the device. Also, it doesn't have to be very big. Yeah. That way I can move the leveler like all the way. And in order to do that, though, I'd have to also have to also bring this out some, like a millimeter or two. I think that's right, right? Let me check. Yeah, okay. So yeah, I'll go ahead and export these and print these out. And they're small enough that, like, I really don't have to change the I really don't have to cut anything out, because, like, it's a measuring spoon, you know. Oh, I thought of something. Sorry. It's okay. I thought of something. Why must it be difficult to fail to solve? Why did it fail to solve? I don't know. Where is the midpoint? I don't know, that looks good enough. And yeah, okay. And then I'm gonna make a plane, add an offset from here, bring it way down there. I'm gonna go ahead and extrude all this stuff. I'm gonna start it at this plane. I'm gonna pull it up to about there. And then I'm gonna go ahead and give these some I'll go ahead and chamfer these edges here. 2 distances. All the way. And then I'm going to go ahead and fillet them. That ought to work. Okay, so what that is that's a place for me to grip with my thumb, so that I can actually, that's a place for me to grab it with my thumb, I can stick my thumb in this area here. So that's what that is. So now I should be able to go ahead and export these and see if they work. And hopefully they'll work. So save as mesh. Okay. Let's see, AO measuring cup. Let me rename. Okay, let me rename this measuring cup and spoon. And then I'll make a new folder and call it measuring spoon. Okay, save. Okay. Save as mesh. Save. Okay, save as mesh. Save. Alright. So this will be a test of how the this will be a test of the function of the mechanics. If this works, I will go ahead and try to add a window here so that I can show off where the what the actual measurements are. If I can do that, I will try to add a window in this, and I'll add an actual handle to this. Also, I'm gonna print in this orientation with no supports, and then I'm gonna print this in the same orientation, and this I'm gonna print in this orientation. So hopefully this will all work fine. It probably won't though, because I mean, look at that spacer. Look at that. I got 3 right here that are just, and I don't even remember what these measurements were. I know this is the 0 point. This one is a 1/4 teaspoon, which puts this one at a 1/2 teaspoon, 3/4 of a teaspoon, or a 1/4 tablespoon, a teaspoon, a 1/2 tablespoon, a tablespoon, yeah. So yeah, I can go and this one's an 1/8 of a tablespoon. I can go basically off of. I probably don't need the 1/8 of a tablespoon, to be honest, but because I've never seen an 1/8 of a tablespoon. I don't think I have anyways. But yeah, I've never used an 1/8 of a tablespoon. I think I've seen a measuring spoon that is an 1/8 of a tablespoon. But if this works, I might actually just change the measuring cup to be the same basic design and shape. Anyways. If the mechanism works, then I'll add a handle to this. And that'll honestly be a handle and a window. And that should do it, because I don't think I'll have the space to add lettering here, because these are 2 millimeters. These are less than 2 millimeters apart. So like, I honestly don't know how I'll do that. I could I just thought of a way to do that actually. Yeah, okay. So, if this works, the way I'm going to make the the way I'm going to put the letters for the measurements is the leveler will act as the line. I will put arrows at that. The leveler will be the line, right, that is pointed to by arrows. The arrows are going to have underneath them the text. Ouch. Ouch. And then the text will be moved around like that. But looking at the size of the text, I don't know if that's going to be possible. So I might just write it very small. I have very small handwriting. I can do that. Or I can carve it by hand. Anyways, now it's time to test this and see if it works. So I'll go test it.